All right, so probability today. And I think this is section 4. Oh, no, it's not 4-2, is it? I think it's 5-6. Okay. 5-6, probability and odds. Okay, so probability is very easy to define. It's just how likely an event is to happen. And to find probability, it's actually really easy to do that too. So let's do an example. Probability of rolling a 3. They always call them a number cube. It's a die, right? Dice is plural. So if I had a 6-sided, oh, I do have one. Oh my gosh. Hold on.
What do you have for us?
Well, yes, I do have it.
What?
I have these, but I don't know how well it's gonna show up. But
We should all get in groups and roll dice.
there is actually a dice lab that we do.
Oh, it's just classic figure. It's only like 4 kids in here.
There's 12, but same idea. So if I had a die and I rolled it, there's 6 sides, right? So if I rolled it, I want to know, well, how likely is it that I'm actually going to land on the 3, for example?
Well, they're on the ground.
It's so, yeah, I know. These big ones are fun to look at, but they're hard to actually like use. I got a 1. I do have little ones though. What?
I'll get it.
Maybe later. Oh, this time I got a 5. Okay, so, but let's figure out how do you actually determine how likely it is that I land on a 3 or any of the numbers. So all you have to do, first of all, there's a shorter way of writing all of that, because that's a lot to write. We can write it like this. So we kind of use these parentheses, and that just means, hey, what's the probability of this thing happening, whatever is inside the parentheses. So it's just a much easier, simpler way of writing it. And here is the formula. All you need is on top, how many ways are there to do what you want to do it over the total number of possible ways or the total possible outcomes. So for rolling a 3, how many 3s are on a normal die? There's just 1. So there's only one way to roll a 3, but how many outcomes could there have been? There's 6. So it's a 1 out of 6 chance of me actually landing on a 3. You can also convert that to a percent. So sometimes you'll see them as percentages. So if I just take 1/6 and turn it into a percent, remember you just do 1 divided by 6 times 100? Is it? So 16.6 repeating percent. All right, so what would the probability of rolling a 6 be? Same thing, right? There's only 1/6 and there's 6 total possible outcomes. Let's make things more interesting then. What would the probability of rolling an even number? So if you stop and think about it, on a normal die, you have the numbers 1, 2, 3, 4, 5, and 6. How many of them would be evens? There's 3 even numbers, right? 2, 4, and 6. So there'd be 3 ways to do what I want to do. There's still 6 possible outcomes though, right? So it'd be 3 out of 6 or just a half. So you have a 50% chance or 1/2 of rolling an even. So if we're playing a game and I'm going to win as long as I roll an even number, I have a 50-50 shot of it happening or not. If I have to roll a 2, it's not looking that good because I only have about a 17% chance that I'm actually going to roll that 2. But maybe I will, right? You never know. Easy so far? Let's do, what's the probability of rolling a 7? Yeah, it's 0 out of 6. There is no 7 on here. So if I'm just rolling 1 die, it's impossible. So if you have 0 out of 6, which is just 0, if you have a probability of 0, that means it's impossible, can never happen. What would the probability of me rolling a number be? 100%. Here's 1/6. 6 out of 6, right? No matter what I roll, I'm gonna get a number. So that would be a 6 out of 6 or 1. So if I get a probability of 1, that means it's definitely going to happen. So all of your probabilities are going to be somewhere in between 0 and 1. 0, it's never going to happen. 1, it's absolutely going to happen. And then you can have anything in between. All right, let's try a different scenario. So instead of rolling a die, maybe I always like to do these. Say I took the words or the word mathematics and I wrote each letter on a card. If I had MATHEMATICS, mathematics. So imagine all of these are like on an index card. So if I take all of these, I shuffle them all up and I say, hey, choose a letter, any letter. Let's find some probabilities. Let's start with probability that you pick. Let's just start with an H. I should say pick an H, not just H. So you're picking a card at random. You can't see what they are. You're just gonna choose one. Well, how many H's are there? There's just 1, so that would be my numerator. And then how many total do I have? 11. So I'd have a 1 out of 11 chance of picking an H. So if I wanted to change that to a percent, I could, and that would be about 9%. However, let's try, what's the probability of picking an M? Yeah, this time I have 2 ways to do that, to make that thing happen. So I would have
There's
2
two
out of
M's.
11 because there's 2 M's, exactly.
And then there's 2 A's.
There would be 2 A's, so probability of picking an A would be the same thing. So that's gonna be probably roughly 18%.
There's 2 T's. There's 1 E. And then there's 1 I and 1 H.
What about this? What would the probability be of picking a vowel? Ooh. Do you remember what the vowels are? Got it. A, E, I, O, and U.
Oh, wait. 4.
Yeah, I have 4 total vowels in this word, right? So that'd be a 4 out of 11. Isn't that fun? Do you remember the word for a letter that's not a vowel? Yeah, consonant. So that's about 36%. So let's do that one too, picking a consonant. So that's any letter that is not a vowel. I think it's 7. Which makes sense because then a letter is either a vowel or it's not. So if there's 11 total and I had 4 that were vowels, I should have 7 that are consonants. 1, 2, 3, 4, 5, 6, 7. 7 out of 11 on that. And that's about 64%. So that's all probability. This is also of a single event. Tomorrow, we're going to look at a more complicated scenario where maybe I pull a card, but then I pull a second card. So maybe, so tomorrow we'll look for things. Hey, what's the probability of you pick an M and then you pick another M? Stuff like that. So that's kind of for tomorrow. Today, we're just going to do one event. Like, hey, if I go to do this one thing, what's the likelihood that it'll happen or not? And let me just make sure, we need to talk about odds still, but let me see if there's any other things that I wanted to mention about probability before I talk about odds quickly. No, I think it's fine. All right, so let me just tell you about odds. We don't talk about odds as much, to be honest with you, but it is important to just be aware of the difference.
You have to flip the page.
I did. Sorry. Did you need stuff from the other page? Okay. So odds, it's like the same, it starts off the same way. I still want to, I'm going to compare the number of ways to do what I want to get what I want. But then I compare it, and normally, I don't know why, probability is almost always written as a fraction, and then odds are written as a ratio side by side. It's the same thing, but then we don't compare it to the total number of ways. It's the number of ways to not get what you want. So let me give you an example. Let me just stick with, let's roll the number cube again, because that's easy. So if I wanted the odds of rolling a 2. Number cube. Again, that's just a die, but whatever, for whatever reason, they love calling it a number cube. So there's only 1 2 on the die, right? So there is only one way to get what I want, but how many ways are there for me to land on something that I don't want? 5, right? So the odds are 1 to 5. The probability, we remember, was 1 out of 6. Odds, though, are a little bit different because it's number of ways to, I almost think of it like winning and losing. So that's my number of ways to win, and this is number of ways to lose. If you ever, I don't know if you've ever seen your parents or guardians or grandparents or someone ever playing the lottery and they have like, there's a little slip of paper and like you can fill out the numbers you want to pick. Or have you seen them like in the convenience store or something? Do you know what I'm talking about?
Yep.
So there's a slip of paper. It's usually kind of like reddish in color and it's always by the lotto stuff and you can pick it and then on that sheet, you just bubble in the answers that you want. If you flip it over, it actually gives you the odds of each. So like, you know, you might win money if you get 2 out of the 6 numbers. You'll win more money if you get 3 out of the 6 numbers, 4 out of the 6 numbers. You get more money as you go out, but the odds change, right? It's a lot harder to get 4 out of the 6 numbers instead of just 2 of the 6 numbers. So if you ever see one of those things, I'll try to remember to grab one if I see one again. If you look at on the back, it'll list the odds of each outcome because it's actually really hard. That's why they can pay so much money for the big jackpots because it's crazy hard to get all the numbers, plus your like special Super Bowl number. Anyway, that's what odds are. You're comparing number of ways to get what you want to ways to not get what you want. So the two are very related, but just that little change. All right, so you try this one. What would the odds be? Odds of rolling a number greater than 3. So think of how many numbers are there greater than 3 on a number cube. That would be your first number. So what number is that? So I got to figure out how many. There's 3 numbers greater than 3, right? 4, 5, and 6. So that'd be your first number. And then I compare it to how many ways there are for me to not get that. So how many, in other words, how many, say it again? It's 3, right? 1, 2, and 3 would be, I would lose. If I'm playing this game and all I need to do is roll a number greater than 3, there's 3 ways for me to win, but there's also 3 ways for me to lose. You can always reduce this 3 to 3. If you think of it like a fraction, doesn't that just reduce to be 1 to 1? Mm-hmm. So what this means when you have something like that, it's equally as likely that the event happens as it doesn't happen. The odds are even. So when they say things like, may the odds be, what do they say? May the odds be in your favor. You know what she says in Hunger Games? If this number is bigger than this number, that means it's more likely that the odds are in your favor. I have more ways to win than I have to lose. Does that make sense? Okay, so your homework tonight actually doesn't have odds on it. It's all just the probability. So let me hand this out and then maybe we'll do 1 or 2 together. Just to make sure that you're not doing odds on us, you're doing probability. Gonna do the whole sheet.
Wait, for the second part, it says one of these cards will be drawn without looking. I'm just looking at number 8. It says P parentheses J. So are you looking for how many J's?
Right.
Oh, so 2. Oh, this is easy.
Yeah, it's really not bad. So let me just do one of them with you. How about, I don't know. So let's just start with number 1 real quick. So this is, yeah. Oh, I'm so sorry.
There you go.
Okay, so number one. Let's see here.
4-letter names, how many 4-letter names are there?
Yeah, one of these
One.
names is to be drawn from a hat.
Two,
Determine the probability of each.
4, there's 4-letter names.
Do we all agree?
Names starting with T.
So hold on. So it's 4 out of what? Say again?
10.
10. We have 10 names? Yes, you can reduce that. You should reduce that. So 2/5. So that means I have a 2 out of 5 chance of selecting a name that's 4 letters.
This is
Oh,
Easy.
you know what you might not know? I'm gonna give you a for 13 to 16. I don't know how familiar you are with decks of cards.
So can we just cross it off?
Oh, I'm gonna give you a printout. Just give me a minute. So just skip those for a second.
7.
Yes.
This is easy.
I told you it was fun. Stop this.